Hello, everybody. So today I'm going to be talking to you about how to conduct a TACAN approach, or also known as a non-precision approach. Now, non-precision approaches are where exactly you're using an omnidirectional signal to help guide you to a certain location. In this case, the threshold of the runway at RAAC. Problem is that the beacon does not care in which direction we are coming from or where our location is relative to the threshold of the runway. It just sits at a location and it broadcasts where it is, and it helps you tell where the beacon is, not where the threshold of the runway is. Unlike an ILS system, which helps guide you specifically to the touchdown zone or to the threshold of the runway, that is considered a precision approach. So when conducting a non-precision approach, it requires a much more greater level of detail and care when executing, and you have to pay close attention to the terrain surrounding the airfield, along with any obstacles or anything else that could be nearby on your approach if you end up screwing up. It also requires a greater level of flying because you have to do what is called a step-down approach, where exactly is in you are essentially cleared at a certain altitude to avoid terrain, and then once you hit a certain distance away from the airfield, you will then step down to the next altitude level that you were able to hit. This is to help keep you above any terrain obstacles or anything that could essentially obstruct the ability of the aircraft to fly. In this case, terrain, radio masts, skyscrapers, anything like that. So, you will have essentially a step down as you go into the airport. Now, normally this would be denoted by charts. Unfortunately, in DCS, we do not have said charts for Syria, Persian Gulf, and one or two other maps. Nevada is the only one that comes with highly detailed charts for pretty much all of the airfields. And if you want to check out me conduct a precision approach that has some of the details for a non-precision approach, look at the ILS video. So, with that in mind, we have to take a look at the terrain surrounding the airfield and figure out what our minimum descent altitude is. So as we can see, RAAC is situated in a valley with hills reaching up to approximately 6,200 feet above the surrounding terrain level, with one mountain reaching up to 8,000 feet. Now, because this is immediately to the west of the airfield, we don't have to worry about that as long as we approach from the north or from the south. So if we look at along the ridges along to the south approach to the airfield, we'll notice that the terrain reaches up to at most 5,000, 5,600 feet. So as long as we maintain above 6,000 feet, we should be good and avoid any terrain obstacles. Same as on the south side, on the opposite side of the airfield. And because of the winds, we will be conducting approach to runway 05, or sorry, 04, which is what we will be doing today. So with that in mind, we know that the terrain that we have to avoid, at least out to about 10 miles of the airfield, is at least 8,000 feet. Even further out, we still have to maintain 8,000 feet. So once we're inside of 10 miles, we can begin our descent as long as we are within this area of the airfield. Now, the way that we are going to do that is that we are going to input the course heading from the omnidirectional beacon, which is this TACAN beacon located at the airfield. And we are going to tell it that when we are heading 041, which is accommodating for the magnetic variance of the airfield, we will be able to line up with the runway within a certain deviation, at most a quarter mile to a half mile. We will still have to make visual contact with the runway, so for non-precision approaches, you have to have a higher level of visibility than what is required for an ILS approach. An ILS approach usually can be conducted with at minimum 3/4 mile to a mile visibility. Non-precision approaches require a mile to a mile and a half of visibility so that the aircraft can see the airfield, see the runway, and line up as it gets closer. We have just barely that with the cloud cover that is over RAAC. It is at 4,200 feet with rain. The base altitude of the airfield is at 3,000 feet. So we can at most get about 1,000 feet off the ground, and we will be able to see approximately between 1 and 3 miles depending on the clouds. So with that in mind, during our approach, we are going to proceed. When we come from the sea, we are going to proceed towards the south of the airfield and intercept the course heading to the airfield, which in this case is 041. We will maintain 041 heading all the way until final and maintain our heading towards the TACAN beacon, which is 24 X-ray at RAAC. Once within 10 miles, we will descend from 8,000 to 4,000 feet, finish our landing prep, and begin looking for the runway. We will hold at 4,000 feet or a little above, and once we've made contact with the runway, we will initiate a landing. If we are too far off from the runway or the threshold, we will go around, climb to 8,000 feet at least, and circle around. Best circle around pattern would be towards the southeast. Alternative would be towards the northwest. And if we circle to the northwest, we will have to climb to at least 10,000 feet to avoid the mountain. And with that, let's get started. All right, so now we're in the F-18 and we are over top of the Mediterranean. So we're going to engage autopilot and we're going to input our TACAN beacon. 24 X-ray, turn it on. Pull up our HSI, set TACAN as receive. We might be a little bit out of the way of the airfield. So we have 72 miles until we reach our approach point. And we're going to set our course heading as 041. So 41 degrees, enter. Okay, course set. Alright, we have now picked up the TACAN beacon. We have verified that our course heading is correct. So now what we are going to do is we are going to wait until we intersect the course line. And then we are going to turn towards the TACAN beacon and try to maintain our course heading of 041. 15 miles to waypoint, 45 miles to the TACAN beacon. Turn to heading 041. Taking a 041 at 41 miles. Zero, back correct left. Okay, corrected left. To the right. Back on heading 041, descending to 8,000. To the airfield, we can see from the mountains bordering the Lookout Valley. We're definitely going to clear it. Left, correct. 2,000 feet to stop. Right now I'm going to keep calling out altitudes to my next step. So we're going to stop at 8,000. Correcting altimeter setting. 2968 is the altimeter. That is giving us an indication we've drifted too far to the right, correcting left, arresting descent at 8,000 feet. Give the autopilot my altitude. And remember, we're going to wait until we are at 8 miles before we will descend to 4,000. Landing light on. Flaps half. We're just going to get in general setup for the approach here. probably tell I'm getting a little buffeted by wind. It's pretty strong up here. A little bit of turbulence as well. Alright. miles, going to start my descent at 11, way down to 4,000 feet by 8. See the mountains off to our left, can't see the mountains off to our right. Descent. Left as well. Descending to 4,000. You're down. Top swap. miles. 1,500.
Altitude. Altitude.
Feet, most of the descent. Left, still a bit off course. Right foot up against the wall in terms of rudder. A lot of crosswind. Visual on runway. Continuing landing. Now it's all visual. Alright guys, I hope that this helps with learning non-precision approaches. It's a tough challenge, but it is a lot of fun once you get to master it and being able to land in weather like this. I will hope to see you in the next video.